Yeah. So heading is torque. So the basic definition of torque is a rotational effect of force. Generally, when we apply force on a body, it will move the body. Like force can move the body or accelerate the body, to be frank. But if you apply a couple of force, like there are two forces acting in such a way that body somewhere it is fixed. And because of the two applied forces, if the object is able to rotate, then that effect of force we will call as torque. Okay. Example, say if I apply force at this point, so this will be moving, this will be moving. If I apply force at this point, this is not moving, this is rotating. So this effect of force we will call as torque. So very simple definition of torque we can say as it is it is a rotational effect of a force. Rotational effect of a force. Another name of torque is couple of force wheels or couple simply means couple of forces and when two forces because without second force maybe holding or maybe rotating we cannot rotate the body actually. There must be another force which is supporting the body such a way that one more force can rotate the body. Remember this point. So that's why we will call it as also as couple or couple of force. Okay. Now the mathematical expression of the torque. Let us see. Mathematically, torque is given by torque is given by tau vector is equals to r vector cross f vector. Exactly like angular momentum only. Nothing more than that. As like we discussed, angular momentum was r vector cross p vector, like position vector cross linear momentum vector. In the same way, rotational effect of a force is nothing but position vector cross force vector. Okay. So as we know already that we can express this like this torque is equals to R F sine theta n cap. Okay. So in this again two expressions possibly. What are those? Torque is equals to R F sine theta separately I am writing n cap and we can also write torque vector is equals to F into R sine theta n cap. Got it? Okay. So now what does these two different expressions of torque means? Let us see. Let us consider a situation. Let there is a rigid body in any xy plane where it is fixed at this point and a force is applied at a particular point somewhere here of amount F. The point of application of force is making a position vector R which is at an angle theta with x-axis. Okay. Now if we expand the equations of this situation, this will be again theta. And if I take the components of R, obviously, components of R, this will be R cos theta, and this will be R sin theta. Okay, let's take it is not fixed here. Let's take it is fixed here itself. Okay, so that axis of rotation we can fix at origin. Okay, here it is axis of rotation. Okay, so this component will be R sin theta. Now see, R sin theta is nothing but, if you observe clearly, R sin theta is nothing but the perpendicular distance between line of action of force. What is this? Line of action of force. Line of action of force. And what is this? Axis of rotation. Line of action of force axis of rotation நடுவில் இருக்கிற perpendicular distance, up the shortest distance is r sine theta. So it is the shortest distance between the line of action of force and the axis of rotation. So we can take this r sine theta simply as r perpendicular. Exactly. If I take the components of f, this is the line of f. So this component will be f cos theta. This component will be f sine theta, where f sine theta is nothing but the perpendicular component of force to the position vector. So f sine theta we can also say as f. So the meaning of this expression, or meaning of this expression, is nothing but this is r times the perpendicular component of force, and this is nothing but f times perpendicular distance between the line of action of force and axis of rotation. So briefly I can say r perpendicular is the perpendicular distance between line of action of force and axis of rotation. Got it? Similarly, F perpendicular I can conclude as perpendicular component of force to the position vector, which is R vector. Got it? So finally, we concluded that torque magnitude is nothing but R F perpendicular or F or perpendicular. This is what we use actually. Yeah, you can give a note point as note. It says that if R perpendicular is zero, what does it means? It means that force is passing through axis of rotation. Perpendicular. At the time only perpendicular distance will become zero. When force is passing exactly through the axis of rotation, what will be the perpendicular distance between them? Zero. So if r perpendicular is zero, which means actually f is passing through what? Axis of rotation. Then what happens? Then torque due to that force will be what? Zero. Torque due to that force will be what? Zero. Understand my point? Okay, very important concept. Basic problems will they'll ask in NEET exam. Example questions I'll write, one or two models we'll see, and then we'll go to other expressions of torque. Okay, look at this example. Let's take a rod of length L and mass M is suspended with a hinge. What is this? Hinge. Hinge means something which is or which makes the body rotatable. I mean, or like a clip, like this. It will be holding like this, so we can rotate the body around it. Okay, that's what we will call as hinge, because there will be questions even from the concept of hinge reaction. Their hinge means what? A support, but it is not like fixed one. About that, the body can be rotated. That is the meaning of hinge. Okay, now the question is, say a beautiful question that I'll make here. A force F is acting at an angle 30 degrees with the length of the rod at a length L by 4 from the one of the ends of the rod. Then the question is, what is the torque due to that force? Or what is the torque of that force? Do you understand? Yeah, how to resolve it? How to simplify it? Either R perpendicular into F you can use, or F perpendicular into R. Anything. Both the formulas are valid, but choosing the formulas according to the given data is the smart way to solve the problem. Both the formulas can be applied. There is nothing wrong in that. But which formula will give the answer in a short way is matter. Like you need to select that condition, right? See, so if I take the components of this force logically, this will be 30 degrees again, isn't it? No, this will be 60 degrees because this is 30 now. Okay, so this is the force line. So this will be F cos 60. This will be F sin 60. Now, if I apply the formula, torque is equals to R into F perpendicular. Perpendicular means what? Which component of the force perpendicular to the position vector? This is x of rotation that now, because rod can rotate about this point, and this is the position vector now. For the position vector, perpendicular component of force is this only, no. So I can say R. R is what? L minus L by 4 into F cos 60. What is the answer? 3L by 4 into F by 2, which is 3FL by 8 Newton meters. Okay, clear? Clockwise or anti-clockwise? Because of this component, the rod will rotate like this, which is anti-clockwise. In our case, it is k cap, according to the plan. Or what if I use F into R perpendicular? Yes. How to do it? F into R perpendicular. If I use another formula, look at the situation very clearly. This is the rod, right? And force is acting like this. Not like that. It's at a distance L by 4, like this. This is axis of rotation, and this is the line of action of force. From the axis of rotation, line of action of force 90 degrees perpendicular distance. No. So this is what are perpendicular. From the line of action of force to axis of rotation, perpendicular distance. So see, as I told you, this angle is how much? 30 degrees. This length is how much? How much? 3L by 4. So R perpendicular we can calculate or not? Sine 30 if we write, what it will be? Opposite R perpendicular divided by hypotenuse 3L by 4. R perpendicular is equals to sine 30 1 by 2 into 3L by 4. So what is the answer? 3L by 8. This is R perpendicular. Substitute here. F into 3L by same or not? What is the answer? 3FL by 8. But here, than calculating this perpendicular distance, taking perpendicular component is bit easier. Understand? So choosing the right formula according to the given condition is mandatory. That will come from the practice of the questions. Nothing more. Clear? Is it? Yes. One more question. One more question. There is a rod placed on horizontal line with two supports. With two supports. No, not with two supports. That will come in equilibrium case. We'll discuss it later. Let's take with only one support. Okay? Like this. Right? Here, I kept 3 kg mass. And this distance is L by 2. Okay. Okay. Let's go with simple question first, and then I will improve the depth. L by 2. And this distance also will be how much? My question is, what must be the value of the mass that I need to keep here so that it will not rotate? Tell me. So that it will not rotate. What is the value of M? Logically, torque must be 0. Torque 0 na? The torque produced by 3 kilograms must be same as torque produced by this M. The torque produced by 3 kg obviously will be in clockwise sign, because this mass will try to rotate the rod like this, and torque produced by this M will be opposite direction, which is in anti-clockwise direction. So torque about the central, obviously it will rotate. This is axis of rotation. So I can say that M into G into perpendicular distance. Idana? Because line of action of force is this. This is perpendicular distance. L by 2 is equals to 3 into G into L by 2. Torque by 3 kg, torque by M. So obviously it will be 3 kg. Equilibrium case. Understand my point? Okay. Really? Now, now see, one more example, important case. There is a there is a disc, circular disc, of radius r. Fixed at its center in a horizontal plane, like this. No, there is a disc and it is fixed, rotatable only. I'm applying a force Ef at the topmost point and applying a force Ef at bottommost point. It is fixed at its center. Now my question is, what is the torque produced by these two forces? Net torque. The net torque. Right. I want to know what is the net torque or what will be the net torque of this situation. So can you say? Think. Axis of rotation is this. Line of action of force is this. This is what perpendicular distance, right? What is this radius? For this also, same logic. This force will produce a torque in. This force will produce torque in clockwise or anti-clockwise? Clockwise. So both torques are getting added or getting subtracted? Added because both are acting in the same direction. So net torque will be F into R, force into perpendicular distance, plus F into R. So what is net torque? Understand? One more question. This question you can see in H.C. Verma book. H.C. Verma rotational mechanics. This model question is there. Okay. Very nice question. And heart symbol will be there. This one H.C. Verma question. Who is there in that room? Who is there? Aki. Aki. Okay. So this is fixed at its center. H.C. Verma Concepts of Physics Volume 1. Green color lo untadi kavanchu. If we get exact question, we'll say. Otherwise, I'll give some data. Okay. So one force is acting 10 newtons like this. One force is acting 20 newtons like this. This distance is given as 5 centimeters. And one force is acting like this, 30 newtons at a distance 6 meters. Okay, there are three forces acting on this heart symbol. So my question is, what is the net torque acting on it? What is the net torque acting on it? Torque due to 10 newtons will be what? Zero. Because it is passing through axis of rotation. There will be no perpendicular distance. Understand? And what is the torque due to 20 newtons? Force into perpendicular distance. 20 into 5 centimeters. Clockwise or anti-clockwise? Anti-clockwise. What about torque due to 30 newtons? Force into perpendicular distance. Clockwise or anti-clockwise? Anti-clockwise. Force if apply panna eppadana rotate agum. Will rotate like this only, no? Yes. Now net torque will be what? 20 into 5 into 10 power minus 2 plus 30 into 6 into 10 power minus 2 Newton meters. Okay. 10 power minus 1, 18. This is 1 plus 1.8, isn't it? So what is total? 2.8 Newton meters. Okay. So calculation of net torque on any rigid body, you must always check what is the perpendicular distance. 90% questions can be solved by perpendicular distance method. Only 10% questions can be solved by the perpendicular component of force. Okay. So understand the concept clearly. What is torque and how to calculate torque? Torque is simply not F into R. F into R means F into R perpendicular, illana R into F perpendicular. So that inner meaning of that F into R perpendicular, R into F perpendicular is important. Okay. Otherwise, even recently one question asked in this one. But what exam? Practice test, part test exam. Recently in repeaters, there is a disc, right? The question was here 9 newtons force, here 4 newtons force, and here 6 newtons force, and here 5 newtons force at an angle 30 degrees. And the radius of this is 20 centimeters. Then what is the net torque? This is the question. Think of it. Think of it. Try பண்ணுங்க. One force 4 newtons, another force 9 newtons, another force 5 newtons, another force 6 newtons. Like this. It is a disk. Then what is the net torque of the situation? Think means solve. I'll give you 2 minutes time. 2 minute है बस. बस 2 minute है. Copy the question and try. I'll check that HC Verma book question once. 1 minute. Try this question. I'll check that HC Verma question in Google. What is the answer? Hmm? 1.5. Sure. What are rotational mechanics? Okay, see. Answer for this question. 1.5. Okay, see. Torque due to this force will be 0. Torque due to this will be 9 into 20 centimeters of day. So it is acting in clockwise. This will be acting in anti-clockwise. This will be acting in clockwise. So let us add these two torques. So torque of this 5 newtons. 5 into perpendicular distance only we need to take. This is what perpendicular distance. This is the line of action of force and this is perpendicular distance. So if it is 20, what about this? This will be 60 degrees because it is perpendicular. So if it is 20, this will be 20 cos 60. 20 cos 60 is 1 by 2 put 10. So it is 10 minus torque due to this 4 into perpendicular distance. Sorry, 20 is net torque. So what it will be? 18 plus 50 minus 80. 50 minus 80. So it is 100, 1.5 Newton meters. Is 1.5? It is in centimeters, right? Without taking this length, how did you get? Components. Okay, that's good. Anything you can take. Okay, I hope you understand. So this is the way that we calculate the net torque always. Now let's get into the stuff of torque in case of rigid bodies. As we discussed, angular momentum in case of rigid bodies was how much? I omega. For a rigid body, what is the angular momentum? I omega. For point mass, mv are perpendicular. Illana m r perpendicular. Like that, what will be the torque? This derivation actually sounds very beautiful if you understand. Okay, this derivation also will be there in H. Verma book, but one of the best derivations that I have seen in rotational mechanics. So let us derive it, and after that I'll give the conclusions regarding it. Actually, the final answer that we are going to get is torque is equals to I alpha. But how does this I alpha comes? Let us have a look. Okay, yes. So you can keep side heading. Torque as angular acceleration in terms of angular acceleration. That is the case. Okay. Yeah. Let us consider a rigid body. Something like this is fixed here. Okay. Its x-axis and y-axis are like this. X-axis and y-axis. This is the axis of rotation. Let me take it little down. This is the axis of rotation. That it can rotate about this point. Okay. And I took a force acting at this point. Let's say point whose position vector is r. Okay. Now think like this. If this force is able to rotate this rigid body of total mass capital M, when it is rotating, this particular point mass appears to be in a what path? Circular path. Obviously. Because it will be rotating. So if it is rotating about a fixed axis, then this particular point mass will be appearing in any circular path of radius r. Understand? Now let us talk about only that point mass or point P, which is moving in a circular path. Okay, let at P A point mass dm is there, and it rotates in circular path. Understand? Circular path. If it is rotating in circular path, what acceleration that it will have? What acceleration that it will have? Centripetal acceleration as well as tangential acceleration. Because we are producing torque here, which means omega is varying. Because of rate of change of omega only, there will be alpha. Whenever alpha is there, whenever alpha is there, omega is changing, then definitely v also will be changing. So speed changing and direction of velocity is changing. Obviously, there will be centripetal acceleration as well as tangential acceleration. And centripetal acceleration will be what? V square by r towards the center. The towards the center I'm taking as r cap with negative. Why negative? You will understand. And tangential acceleration we know already. dv by dt. This is along t cap, tangent direction. Because the tangential acceleration will be acting like this. Centripetal acceleration will be acting like this. AC and AT. Now you understood, right, why I took minus r cap? Because it is exactly opposite to the position vector. Position vector will be always from the origin to the outwards. From the origin to the outside. That is what r cap. Opposite of that will be minus r cap. Understand? Okay. So now net force will be what? M into net acceleration. Isn't it? What is that M that we are considering here? dm, point mass. Net acceleration is what? AC vector as well as AT vector. Got my point? So dm into AC vector is what? V square by r minus r cap plus dv by dt into t cap. This is what? Yeah. Now, dv by dt is nothing but linear acceleration, which is nothing but r alpha. Rotational motion, not rotational, circular motion, we studied about this. V is equals to r omega. A is equals to r alpha. X is equals to r theta. The relation between angular quantities and linear quantities. Since the tangential acceleration is linear acceleration, we can write it as r alpha. So now becomes dm into v square by r into minus r cap plus r alpha r alpha into t cap. Now we have got the force, right? Now torque will be what? What will be the torque produced by that force at that point P? Torque will be what? R vector cross F vector, isn't it? Which means R vector cross dm into v square by r, okay, into minus r cap, okay, plus r alpha into t cap. Here have a look once. Actually this is d torque we can write because we are taking dm. Okay, now see, very important point. If I take the cross product of this two, what we will write? Cross product of this two, this vector cross this vector, dm into v square by r, magnitude is like that, r vector cross r cap. R vector direction is away from the center, minus r cap direction is towards the center. What is the angle between these two vectors? 180 degrees. What will be sine 180? So it will be 0. Understand or not? Plus r vector into r vector. Magnitude is r square. Magnitude is r square into alpha as such. R vector direction is like this, as I told you, and tangential vector direction is like this, t cap, isn't it? So what is the angle between them? 90 degrees. What will be sine 90? Understand? So what is the final conclusion? dm into r square into r. N cap will come, that I will mention at last. Magnitude let us take. D tau. So what will be the total torque if I take for the entire body? Integral of d tau is equals to integral of dm into r square. Okay, that is nothing but alpha into integral of dm into r square. Integral of dm into r square is nothing but di, moment of inertia of a point mass about any axis of rotation. So what it will be? Alpha into integral of dA enagum. So what is the final conclusion of the torque? I alpha. It will be k cap, because one vector is like this and one vector is like this. The cross product of these two vectors will be perpendicular to this plane. So what is net torque of the situation? I alpha. As net angular momentum of rigid body is I omega, net torque of the rigid body is what? Derivation table. Actually, derivation is not required for the NEET students. But long back I derived this, so I wanted to check whether I can derive it or not. Almost 1.5 years back. Understand? So the net torque acting on any rigid body, net torque acting on any rigid body is always given by I alpha. What is I? Moment of inertia of that rigid body. What is alpha? Angular acceleration. Okay. Okay. Yes. See, now one example and then we'll go to the case of relation between angular momentum and torque. That is the last one related to the torque. Time is there? No problem. Okay. Now let us write one example. Let us try. There is a disc having a support at its center and a force of amount F is applied at the topmost end. Its mass is M and radius is R. Then what is the angular acceleration of this due to the force? What is the angular acceleration of the disc due to the applied force? Tell me. Tell me. What will the net torque acting on it? Force into perpendicular distance. And mg will be acting, of course. But that will be passing through axis of rotation now. Whenever a force is passing through axis of rotation, torque will be zero. So only F can produce the torque here. So what will be that torque? F into R is equals to I alpha. So F into R is equals to I. Moment of inertia of a disk of mass M and radius are about its central axis or center of mass axis. What is the formula? Mr square by 2. That's good. Into. So 2F by M is angular. Let me point here. Yes. So like this, they'll ask questions. Pardon. One more example. One more example. Is there is a cylinder, another cylindrical body, solid cylinder I am taking of mass M, radius, is being supported with a string like this. Okay, the string wind panni, हम अपने attach panni, we left it. When we leave it, how it will be coming down? Rotating and coming down only, no? Exactly like this. I winded a wire, okay, and these two ends I just attached to a support and I left it. So it will be coming down like this only, by unwinding it. So when it is coming like this, definitely it will be rotating and coming. So it will be having some angular acceleration. What will be that angular acceleration? That's my question. Tell me. Little deep question, but easy now. Who will produce torque here? Tension force will produce the torque here because string will be attached to this at edge. About the string, it will rotate and come. What is the matter? Understand? So string tension force. I think your brother. Driver. Yeah. So string will be like this, right? So tension force because it is on edge, right? On edge. Force into perpendicular distance. Okay. So we can write what we can write net torque another tension into radius plus tension into radius. Why? Because at both the ends it is there now. Understand that? Is equals to I. So 2Tr is equals to moment of inertia of a solid cylinder about its center of mass axis. Mass square by 2 into R. What will be alpha? 4Tr by, let it be T itself. Because to calculate the T again we need to go back to laws of motion. Male 2t down mg, so 2 mg minus 2t is equals to ma. Again a we need to take r alpha. Again if we substitute the conditions of these two equations, then only we'll get the exact value of alpha in terms of a or g, not in terms of t. So let it be up to t itself. Understand that? 1 minute, sorry, a small calculation. What will be the answer? 4t by mr. Yes, sorry. Another radian per seconds. Got it? Okay. So this is the way that we calculate the torque. Angular momentum, torque, and the approach of calculation of angular momentum and torque. Now, finally, the last point of the day is, as we all know, in laws of motion, Newton's laws of motion, we studied that the rate of change of linear momentum with respect to time is always equals to net force. You remember Newton's second law? Exactly, the rate of change of angular momentum is always equals to net torque. And we also know that impulse is nothing but force acting on a body for a small interval of time. Exactly, angular impulse on a body is torque in a small interval of time. Understand? This will be equals to change in linear momentum. This will be equals to change in angular. This is the sweetest point of the day. Okay. So conclusion, overall conclusion of the concept is whenever any force is able to rotate a body about any fixed point, then that force can produce torque. So the rotational effect of the force is known as torque, and mathematically torque is given by the cross product of r vector and f vector. That can be expressed in two ways. One is r f sine theta, if we split it into parts as like r into f sine theta, or f into r sine, where r into f sine theta is the position magnitude multiplied by the perpendicular component of the force, and f into r sine theta is force magnitude multiplied by the perpendicular distance between the line of action of force and the axis of rotation, which means the perpendicular distance between the two lines. Okay, so according to the given situation, either you can choose f into r perpendicular or into f perpendicular, and both will give the same answer. Okay, next, according to the application of the torque force, the torque produced in case of any rigid body is given by I alpha, where I is the moment of inertia of the rigid body and alpha is the angular acceleration. And the relation between the angular momentum and torque is given by delta L by delta T is equals to torque, as like delta P by delta T is equals to net force. And impulse is given by force into time, and angular impulse is given by by torque into time. And it will be always equals to linear momentum, and angular impulse is always equals to, that's all. So based on this, we need to solve some questions that we can proceed in next class. And I'll share you one worksheet in group. You please go through each and every concept after we discuss, and each and every problem that I share in worksheet, please. So by listening, you may understand physics, but not solve physics. You have to practice the question to solve the questions of physics. Definitely. Okay. 1 minute. First, I'll share the question paper in the group, and then I will share the notes.